vector chapter. So let's vector. Okay. So today we'll look out briefly and in-depthly about the vector chapter, and we'll go through first of all basic things, and then we'll go in little depth. Okay. So first of all, starting with the vector, what is the meaning of vector? What is the meaning of vector? Okay. If we have any physical quantity, if we have any physical quantity, let's say there is a mass. We can take an example of mass. Mass is what? Mass is a physical quantity. Okay. So any physical quantity will have a magnitude and a direction. Any physical quantity will have a magnitude or a direction. Okay. It can have a magnitude. It can have a magnitude or direction or both. Or we can write it more clearly like either a magnitude or direction. If any physical quantity has only magnitude, then those physical quantities are known as what? Those physical quantities are known as scalar quantity. Any idea? Okay. See here. Any physical quantity, any physical quantity which has which has only magnitude, which has only magnitude, any physical quantity which has only magnitude is known as scalar quantity. Is known as scalar quantity. Is it clear? What quantity that has only magnitude? For example, we can write some examples like distance. Distance. How we are measuring the distance? Distance is measured in meter. Distance is measured in meter. So there will be a value. There will be a value existing for the distance. Let's say if it is 2 meter, 3 meter, 4 meter, let us consider it is 2 meter. Okay. It means a scalar quantity will have only magnitude. Scalar quantity will have only magnitude. Okay. So this is the part you need to highlight. If there is a quantity which is only scalar, then it will only have magnitude. Okay. Now next this was first one, like we were dealing what is scalar quantity, and next we will deal with what is vector quantity. Second, what is vector quantity? What is vector quantity? We'll see this. Okay. So look here, any physical quantity which has magnitude, any physical quantity which has magnitude as well as direction. Okay. Any physical quantity which has any physical quantity which has magnitude as well as direction are known as vector quantity. Okay. Any physical quantity, any physical quantity which has magnitude as well as direction, as well as direction is known as vector quantity. Is known as vector quantity. Okay. If you have a quantity and it contains a magnitude as well as direction, then it will be a vector quantity. Can we take some examples? So we'll go through some example. Let us consider displacement. Okay. Displacement. So why we are saying that displacement has only, actually displacement has magnitude as well as direction. Why? What is the reason behind this? What is the reason behind this, that we are saying that a vector quantity will have magnitude as direction? Okay. So here, look here, If there is a 2 points, point A and a point B, okay, and between point A and B, a line is existing, a straight line. What is what it is? It is a straight line. Okay, it means between point A and B, we can have multiple paths. If a body start from A, if a body start from A and it move from A to B, then it can have multiple paths. Either it can go in a curved path, either it can go in a like straight line, something curved, bending parts, bending path. Okay, so it can have multiple paths. The body can have multiple paths. Let us consider this is path 1, this is path 2, and this is path 3. Okay, so what is the shortest length path? Which path is very very short? Can you tell me? Which path is very very short? The path 1, isn't it? Is it clear? The path 1 is very short. Path 1 is the shortest actually. Okay, so the shortest path between 2 points is known as displacement. What it is? The shortest path between 2 points is known as displacement. So this is what? This is nothing but displacement. This is displacement. It means what? It means if we have some certain point A and B, if we have some certain point A and B, then the shortest path or the displacement will be in the fixed direction. It will be in the fixed direction. Okay, so this is displacement. Okay, means if we have a 2 point, then the direction of the displacement will be fixed. What in the case of distance? What will be in the case of distance? Is there any fixed direction for distance? Path 2 and path 3 are nothing but distance. Path 2 and path 3 are nothing but they are indicating the distance. Distance is nothing but like the actual path which you are following, and what is the length of that path. That actual path length will be known as a distance. Okay, that path will be known as distance. So if we have a point A and a point B, so we can have multiple distances value. We can have multiple distances. Okay, we can have multiple distances, but the displacement will be fixed. Displacement will be fixed value. Its direction will be also fixed, and its magnitude will be also fixed. So between point A and B, there is a straight line which is indicating its displacement, and which is in fixed direction. Which is in fixed direction. Okay. So I think I'm clear with the distance and displacement and scalar quantity and vector quantity. Any quantity which will have only magnitude, that will be known as magnitude as well as direction. Magnitude as well as direction, that will be known as a vector quantity. Okay. Any physical quantity which has magnitude as well as direction is known as vector quantity. And here we got the example which was displacement. The example. Okay. Now, what is the importance of vector? Like, first of all, we are dealing with the vector. So what is the importance of vector? Why we are studying vector? Okay. So the importance of vector, we can say that vectors are useful in practical problems of mechanics and geometry. The vectors can be useful in practical problems of mechanics and geometry. Okay. And vector analysis is powerful tool. It is a powerful tool to formulate equations of if there is a particle and it is doing some motion. So in order to analyze its motion, vector can be a analysis part. Vector, by with the help of vector, we can analyze that how is the motion is happening, and we can, with the help of vector, we are solving them in mechanics and engineering. Mechanics and engineering, we are solving all these things. Okay, now we will see. So I think you everyone is clear with the importance of vector. What is the importance of vector? I'll call it again. Vectors are useful. They are useful in practical problems of mechanics and geometry. They're useful in practical problems of mechanics and geometry. Okay, and its analysis can be a powerful tool to formulate equations of motion of particle. Its formulation or it its analysis can be a powerful tool to formulate equations of motion of the particles and solve them in mechanics and engineering. Okay. Now we'll deal with what is the representation of vector, how we will represent vector. So the next one will be representation of vector. I think I'm clear with the importance of vector, right? Representation of vector. It means how we will represent a vector. Look at here. To represent a vector, okay, to represent a vector or any vector quantity, we'll make a arrow on the top. We can write it like, to represent a vector, we use boldface type. Boldface type. Example: velocity of an object is represented by v. Velocity of an object is represented by letter v. Little bold. Okay. Since boldface is difficult when written by hand, so a vector is often represented by an arrow placed over a letter. Every time we cannot make it like a bold, right? It will waste our time. So instead of bold, or we can write it just V and a arrow at the top. Okay. So these are the representation of vector. Representation of vector quantity. So if we are want if we want to represent a vector quantity, so we need to either use a bold letter or a letter, it's a starting letter and a arrow at the top. Representation. Okay, so he can see here you can see the arrow at the top and a letter, and here also the bold letter, and this is what this is representation of vector. Is it clear? Am I clear with this? Okay. So if you are clear with the representation of vector, then how we will indicate its magnitude and how we are indicating that it is indicating some, or it is has some direction. So the magnitude of vector, the magnitude of vector, the magnitude of a vector is often called its absolute value, indicated by capital V, or we can write just small v, arrow at the top and a mod sign, is equal to normally V. Either we will represent its magnitude the capital V or a small v or a arrow at the top and mod sign. These all three types will indicate the magnitude of vector. Is it clear? These all three will represent the magnitude of vector. Okay. So now we'll come to the in addition to magnitude and unit, how we will do the addition and what are the different law of vector in addition. So in addition to magnitude and unit, in addition to magnitude and unit, we can write it like, in addition to magnitude and its unit, first point, it has a specific direction. It has a specific direction. It has a specified direction. Okay. Second, it obeys parallelogram parallelogram law of vector addition. It obeys parallelogram law of vector addition. It obeys what? Parallelogram law of vector addition. Third, their addition is commutative. Their addition is what? Commutative. Okay. It means what? Like if we have two vectors, let's say A and B, and we have a vector, so we are making a sign at the top, plus b vector. We are adding two vectors, so this is also equal to b vector at arrow at the top plus a vector. Both are same. Both are same. These are not a different quantity. Both are same. Okay. Take. Means their addition will be commutative. What are the highlighted points? That addition will be, their addition will be commutative. Second, it will obey parallelogram law of vector addition. It will obey parallelogram law of vector addition, and it will have a specified direction. Okay, these are the highlighted points that it will contain. Okay, now we'll see what is the graphical representation. What is the graphical representation of vector? Graphical representation. What is the graphical representation of vector? So in order to start, first of all, what is the graphical representation of vector? Anybody can tell me what can be the graphical representation? How we will represent a vector graphically? Any idea how we will represent a vector graphically? Can be represented with the help of arrow, which will contain a head and a tail. Which will contain a head and a tail. Okay. Like, in order to indicate a vector, we'll make an arrow, and it will contain this tail part, and this will be nothing but a head. Okay. It means what? It means what? Any vector, if we are representing it graphically, then it will have a tail, head. Okay, a tail and a head, and the length of the arrow, will indicate what is the magnitude of vector. So here is this length. This particular length will represent or show the magnitude of vector. The magnitude of vector. Okay, so graphical representation of vector. How we are representing? We are representing with the help of an arrow. We are representing with the help of an arrow. Okay. Okay, this is the graphical representation of vector. Now we'll move forward and we'll look a question. We'll move forward and we'll look a question, and then we'll solve it. Let us solve a question. In the question, they have said represent two forces. Represent two forces. For better clarity, you can watch this video on 2x speed so that you'll cover the content in very short time. Okay. Represent two forces, one of 50 Newton due south, and other of 25 Newton, and other of 25 Newton due east, comma, acting simultaneously. These two forces are acting simultaneously on a particle. These two forces are acting simultaneously on a particle. So we need to represent. Our two vectors in this. Okay. Is it clear? So everybody read the question and tell me what will be the appropriate solution in graphical view for this particular question. See. Should I start now? Okay. There are two forces, right? And one has a 50 Newton magnitude. It is in south direction, and the other has a 25 Newton magnitude in east direction. As far as I know that, or I understand that, you should know this direction. This is what? This is north, this is south, this is east direction, and this is west direction. I think everybody is clear with it. So here in this, what they have said, one force is 50 Newton due south. Okay. So if we are considering this is the center point, in this is the center point. So due south, and towards south, the value is how much? It has gone 50 Newton. Okay. And the other force is 25 Newton due east. Okay. It means from here, one is force is acting due east, how much? 25 Newton. It is in east direction and this is in south direction. So these are the things which you need to understand. Okay, so how we will represent these forces in graphical mode? So what we'll do, we'll take a graph paper, we'll make a origin in the center, we'll make a origin at the center, and let us consider that 1 Newton represent 1 centimeter. 1 Newton represent 1 centimeter. Or we can also, for simplicity, we can take it as, let us consider that we will take 1 centimeter represent 1 centimeter represent 10 Newton. Okay, this will be our more simple. Okay, look at here. So 1 centimeter is representing 10 Newton, right? So we have 10 Newton which is equal to 1 centimeter. According to our assumption, which we are going to make for graphical representation, 10 Newton we have taken equal to 1 centimeter. So what will the value of 1 Newton? 1 Newton will be equal to 1 upon 10 centimeter. Isn't it? That is nothing but unitary method. We are solving by unitary method. So we'll move forward and we'll look at here. So 1 Newton is 1 by 10 centimeters. So what will the value of 25 Newton? That will be nothing but 1 by 10 into 25 centimeter. So we'll got the answer as 2.5 centimeter. So in order to represent 25 Newton on a graph paper, we have to take the length of 2.5 centimeter. Okay, is it clear? So now look at for 50 Newton. Same will do it for 50 Newton. And how much 50 Newton, how much centimeter length we have to take in order to represent on a graph sheet. Okay. So what we have assumed here? We have taken that 1 Newton is nothing but 1 by 10 centimeter. This lecture is basically for those students who are very like at the basic level. They don't know anything about the vector. So this video is totally helpful for them. And for advanced purpose, I will also make for advanced purpose video like something kind of like PYQ questions for NEET and JEE. So slowly, first of all, I will go through the topic of the basic students. Then I will slowly will increase the level of the lecture, and then we'll go through the PYQ questions also. So keep on trust us, okay, and be patient. Be patient, keep the patience, and we'll move forward. Okay. So the 1 Newton was equal to nothing but 1 by 10 centimeter. So in order to represent 50 Newton, we have to take by unitary method 1 by 20 into 1 by 10 into 1 by 10 into 50 centimeter. So the value will be how much? 50 by 10. 50 by 10 means 5 centimeter. So is it clear? Like in order to represent these two forces, that is 25 Newton and 50 Newton, in order to represent these two forces, that is 25 Newton and 15 Newton, how much length we need to make? How much length we need to make? We need to make. So tell me how much length we need to make? So for 25 Newton, the length will be 2.5 centimeter, and for 50 Newton, the length will be 5 centimeter. Is it clear? So if you consider a center point, so for 25 Newton, which is in east direction, can you look at here? Look at here. 25 Newton, which is acting in east direction, and 50 Newton, which is acting in south direction. Now this we will represent on a graph sheet. Okay. So look at here. So if we take the center point here or the origin at here, so our 25 Newton and a 50 Newton. So in order to represent 25 Newton, we are taking 2.5 centimeter length, and in order to 50 Newton force, we are taking 5 centimeter length. Okay, from center point we are taking 2.5 centimeter. Make it clearly, make it clear that we will take 2.5 centimeter, and from center we will take 5 centimeter. Okay, 2.5 centimeter and 5 centimeter we will represent. Is it clear? Is it clear? Okay, so we'll move for the second question, which is little high level increasing. Okay, so the next is draw vector corresponding draw vector corresponding to the following displacement, to the following displacement to the following displacement you need to draw the vector. Okay, so the first part is, or the first question is in this is 6 meter comma 60 degree northeast, 6 meter comma 60 degree north east direction. It means we have to draw the vector, we have to draw the vectors of length 6 meter. We have to draw the length of 6 meter. Look at here, we have to draw the length of 6 meter in 60 degree northeast direction, northeast direction. Now look here, if we indicate this direction, this is north, this is south, this is east, and this is west. These are the direction, right? So we need to take in northeast, right, and 60 degree northeast. How much they have said? 60 degree northeast. Now focus here. So this, if this is the origin or this is the center, so from east direction towards north, from east direction towards north, we will take 60 degree angle. We'll measure the angle from the east direction, and we'll measure a line, or we'll make a line which is of length indicating 6 meter, and it is inclined at an angle of 60 degree from the east direction. And this direction is what? This direction is nothing but north east direction. This is northeast direction. Is this clear? Is this clear? Second part is, second question is in this is 6 meter west. We need to draw a vector of 6 meter west. So we can see west is in this direction, west direction is this. So what we'll do, just we'll make a center point O, and just we'll make a vector in this direction, which is of 6 meter. That's it. So that's it for the lecture. It was a very brief introduction about the vector. In the next further lecture, we'll do the in-depth study about the vector, and we'll study so many things in the vector. So currently this is just a basic part and just an intro part of the vector chapter. Okay, so thank you for this lecture attending, and soon we will start a new lecture or a next lecture on a little advanced topic. Okay, thank you.